So this is a problem from section 1.8. Okay, here's a question. Okay, the question says that use the intermediate variance theorem to show that there is a root of the equation in the given interval. Okay, so show that this equation x to the fifth minus x cubed plus 3x minus 5 equals 0. This equation, has at least one root in the interval from 1 to 2. Okay. Now, how do you prove that? What does it mean there's a root? So if you consider the function f of x, if you, let's call it f of x. So, okay. Then you have a graph, right? So you have a graph, y equals f of x. So solution means this is 1, that's 2. This is a graph that at least this graph will intersect with the x-axis at one point, right? So this is y equals f of x. Okay. You have to prove that this graph intersects the x-axis at least one point between 1 and 2. At that point is a root. Okay. Now, how do you prove this graph intersects the axis at one point between 1 and 2? All you have to do is by the intermediate variance theorem, the values of the function at the two endpoints of the interval have the opposite sign, right? One is maybe below the axis, other one is above the axis. So let's see what is the value of f of 1. F of 1 is 1 to the fifth, 1 cubed, plus 3 times 1 minus 5. And this is negative 2, okay? This is below the x-axis. Then you look at the value of this. It's 2 to the fifth minus 2 cubed, plus 3 times 2 minus 5. Let's simplify it, okay? So how do you simplify? You take 2 cube out, then will be, yeah, there's no standard way to do that, right? So 3 times 2 minus 5 without using calculator. Okay, so it's gonna be 2 squared minus 1 is 3, right? So you have 8 times 3 plus 3 times 2 minus 5. And then you can say take 3 out, you get the 10, right? So 30 minus 5 is 25. Right, it's 25. So 25 is positive. So that tells you one end of this curve is above the axis, another end of the curve is below the axis. So the curve is not broken, right? The graph is not broken. So there is the intersection. So you can say that by the intermediate variance theorem, okay, fx has a solution in the interval from between 1 and 2. That's it. So this is argument. All you have to do is to verify that the values of the function at the two endpoints have the opposite sign. Okay. Intermediate variance theorem is an important application of calculus. Otherwise, it's hard to see, why there's a solution of this complicated equation. Today, we're going to study derivatives. Okay, so in calculus 1, 3 important topics. One is the limit. Second one is derivatives. Third one is integrals. So we are now studying derivatives. Okay, so derivatives, first I have to give a definition of the derivative. right? And then we try to understand the meaning of the derivative. Okay, so first of all, let's define. Let's understand the definition of derivative. Okay, so this is the definition of a derivative. So f of x is a function, be a function defined on some interval, okay? And so a function on some interval, and the number a, and a number in the be a number in the interval, okay? So if it's in the point, we can only talk about side limit. If inside the interval, we can talk about leg limit. So the limit of this quotient, if it exists, is called the derivative of the function, and that's the notation, f prime a. So it's called the derivative of f at a, okay? Now, what's the meaning of the derivative? The meaning of the derivative is actually here as a slope of the tangent line, okay? The geometric meaning. The geometric meaning of the derivative is the slope of the tangent line, okay, at this point. So here's a picture, right? So this is a, and this is an arbitrary x nearby a. So look at this secant line. This is a p, that's a q. Okay. So the slope of the secant line, if you want to express it, so the difference of the y coordinates. So the y coordinate, if x coordinate, if it's, yeah, this is x coordinate, then the y coordinate would be f of x, and that's a and f of a. So the difference of the y coordinates over the difference of the x coordinates. So that is actually this quotient is just the slope of the secant line. So the slope of secant line approaches the slope of the tangent line as q approaches p along the curve. Okay. So what is a p? P is the limit. So the limit, if it exists, is just the slope of the tangent line. So in other words, yeah, this is f prime a. So f prime a is the slope of the tangent line at the point a and the f of a. All right, that's it. That's the geometry meaning. And if the function is a position function, then the slope will be the instantaneous rate of the instantaneous velocity at that point. If some quantity is given by f of x, then the derivative is actually the instantaneous rate of change. So take a look at example. We have f of x equals 1 of x. Right? Find the general formula of this, where a is not going to be 0, because the way 0, the function is not defined, so you cannot talk about the limit. Okay. How do you do that? So you write down the definition. Okay, otherwise we don't know what they're doing, right? So write down the definition. That's going to be x approaches a. Here, x minus a. So what is it? What is here? This will be f of a. That's f of x. Yeah, 1 of x minus 1 of a. Okay, so that is if the limit exists, that is the derivative of the function. Okay. Yeah, according to the definition, right? So this is f of x. That's f of a, right? Yeah. So the next question is, how do you find the limit? You have to simplify. Okay. You have to simplify. You cannot just plug a for x into the denominator. Then it's going to be 0 as the denominator. So you will get a times x, a minus x over x minus a. Right? Then express in this form. Can we cancel x minus a? Yes, because the numerator is a minus x. A minus x is going to be negative x minus a. So you get x minus a, then that will be canceled out. So you get negative 1 ax. Good. So this is a simplified expression. Now you let x approaches a. If you let x approach a, x approaches a, so this function approaches a times a, that'd be a square here, 1 over a square. So that should be the limit. Okay. So this is f prime a. So we find out. We just call it the f prime. So we find the limit. Okay. In other words, we find if f of x equals 1 of x, you find the derivative of the function. Okay. I'm going to change the variable to, yeah. So think about this. F of x equals x to the negative 1. Then we get, right? You get this. Good. So we keep this. Okay. Then you look at the next problem. You get x squared and find f prime a. Okay, let's do it. So how do you get that? This is going to be the limit as x approaches a and x minus a, fx minus f of a, right? So let's put details here. It's x squared minus a squared over x minus a. I'm going to find the limit of this expression. We can simplify it. Okay, so x minus a cancelled out. You get x plus a. Then you let x approaches a, you get 2a. Great, that is my derivative. All right, so let me write down what do we have here. If f of x equals x squared, then this is going to be 2a. Okay. We list this on the side. And we continue to do exercise. Okay. How about x cubed? How about square x? Okay. Yeah, let's try to square x. X cubed, there's no technique, there's no difference. You use it. Okay, so let's look at f of x equals square x. Okay, I'm going to find f prime a. Okay. For the same reason, I just look at this expression, okay? It's square x minus square a and the x minus a. I want to find the limit as x approaches a. So I try to cancel x minus a in the denominator. But how do I do that? Well, I multiply the numerator by this number. Okay. Well, then the numerator is going to be x minus a and x minus a, and here square x plus square a, and that cancels out. All right, so this is what we get. Okay, then you let x approaches a, then you get twice of square a, which is a derivative of the function. So I'm going to list this here. But this is so now we got 3, right? But this one I can write in another form. I can write it in this form, x equals x to the 1/2. Then f prime is going to be 1/2, and a to the negative 1/2. So now we stop here. We look at this what we got. Okay, we look at what we got. If fx equals 1/x, no, we use the notation. We use a function. Then you get, right? If of x is x squared, then you get twice of a. If of x equals x to the 1/2, you get 1/2 a to the negative 1/2. Okay, so I find out, I make a conjecture. I look at those 3. Then my conjecture is, if f of x equals x to the alpha, then this should be, oh, doesn't matter, just put a k on that. Then this will be alpha times x to the power decreased by 1. Yeah, decreased by 1. So if it's originally is 2, then 2 minus 1 becomes 1. Then you try to check whether it's true in general. So being a scientist or biologist or mathematician, that's what you have to have this talent. You look at the samples, right, do one by one. Then you shouldn't continue with the time. You should realize that, hey, maybe there's a logic, pattern you figured out. Then you make a conjecture, then you can verify by another experiment, or in mathematics, maybe you have to find another way to prove this is true in general. Okay, so I do give not this exact same problem, I give another similar math problem to 2 different kids. Okay, and then one child, after repeatedly doing the problem, and I changed the number a little bit, right? And then the third, and he just realized, oh, I know what is the next. So I know the answer. I don't even do it if you give me similar problems. And but another student just repeatedly doing 5 times, still did not pay attention to the problem, and cannot make a conjecture, figured out this is true in general. So there was some difference. Some kids do have this talent, so can continue in the direction, study to, I think it's necessary. It's just, even simple problems, you should, when you look at this, you should figure out the pattern, okay? Then if you couldn't figure out pattern, then save your time, and even general, you write down the general statement, and if it's important discovery, and your name will be associated with that, okay? Yeah, so you should be always being alert for some phenomena. Right. All right, so we get this. Then I'm then if I given this problem, right? Find the derivative of this, right? I can write down the answer right away because I know this should be equal to 3, and a 3 minus 1 is 2, right? And I can prove that directly. You know, I can do that. Then I find out indeed this is answer. Then my in biology, then you can just say claim this is true in general. But in mathematics, it's not proof. You only verify by the examples. Okay. And how do you know this is even verified by 100 examples? Does not mean this is always true. Sometimes it's very interesting for a very sufficient large number, it's wrong. Okay. So you cannot just say this is true in general. Okay. So there's a small difference being a biologist and being a mathematician. Okay. So let's verify this by example. Okay. Yeah. Let's double check whether this is true or not. Okay. I'm going to look at this. Okay. And then that's going to be x cubed minus a cubed, then x minus a. I have to find the limit of this. Okay. So how can I do? I fact the numerator. I hope you still remember the formula. It's going to be x times a plus a squared and x minus a. So x minus a cancelled out. I will get x squared plus ax plus a squared. So if I let x approaches a, what I get is a squared, which is 3a squared, and that is the derivative. Indeed, we got 3a squared, not surprised. Okay. So some students can figure out the general formula after then 4 problems. Some students still couldn't see the general pattern after do 7 problems like that. So it's there's a small difference. Okay. You can so we get the formula. Okay, let me state the theorem. Okay, this is should be the result we can use over again. Not again. Okay, this is true. Okay, that's true always. We are not able to prove it here, but we accept this fact. Okay, so in the future, we don't need to use this limit to find the derivative. Okay. All right. Here's another way to express the limit. You see, f prime a, right? So we use this is our original definition. But if I change the variable, I let h to be x minus a. Then what do you get? Here's h. X will be a plus h, and so this is another formula for the derivative. Okay, so make the denominator simpler, just h instead of x minus a. Okay, you can also use this to find the limit. Okay, you can also use this to find the limit. Okay, so let's take a look at the following example. So if we have f(x) equals x square minus 2x, okay? Find f prime a. Okay, so here's a sum of two power functions. Okay. At this moment, we don't know if we differentiate, if we find the derivative of this, the sum of two functions, whether or not we can just add the derivative together of each term. We don't know. We later on we can prove that theorem. It's true. Okay, we can do that. But right now we just use the definition. limited definition to find the derivative. Okay, so you needed to look at I'm going to use a new formula, use the h here. So a plus h minus f of a divided by h. Okay, so that is going to be a plus h squared minus 2a plus h. That's a first function, minus a squared minus 2a divided by h. Okay. So let's simplify the numerator. We can get rid of h. So a plus h squared will be a squared plus 2ah plus h squared minus 2a minus 2h. Okay, so minus a squared plus 2a divided by h. A squared cancelled out, 2a cancelled out. So how many terms do you have? You have a 2h plus h squared minus h. So I can take a h out. Okay. Right, take h out of each term. You got 2h times 2a plus h minus 2. So h cancel out. So after you simplify, you get this. All right, now can you find the limit as h approaches 0? Yes, it's easy to see that. This is the as h approaches 0 be 2a minus 2. So that is the derivative of the function. So you find the derivative. Okay. Yeah, we are going to learn more formulas in the next section using formulas to find the derivative. But right now, the only formula we figured out is the power function, the derivative power function. Okay. Yeah, let's look at the next problem. So here's the f of x. It is going to be 1 over x squared. Find the derivative of a. Here's a is not going to be 0. Now, if you use a formula, you can get the answer quickly, okay? The formula says that if you can express this as x to the negative 2, right? So f prime a is going to be alpha is negative 2, right? So negative 2 times a here, negative 2 minus 1. So it's going to be 2a to the negative 3. So using the formula, you can quickly get as a derivative. Now, if you don't have the formula, can you find the limit? Okay, so the derivative is all, use the limit definition. Yeah, there is always a problem there. Ask you to use a limit definition to find the derivative, okay? You cannot just give me the answer. Sometimes the answer is given. So this is the f of a plus h minus f of a. So you have to find this limit. If you are asked to use a limited definition to find the derivative, no choice. All right, so you know the answer already, just to show me how to get this answer. So this is going to be, yeah, let's look at a plus h minus f of a divided by h, right? So that would be a plus h squared minus 1 over squared here. We needed to simplify this expression and eventually get rid of h in the denominator. Otherwise, you're not able to find the limit. Okay, let's do it. Here's h. And this will be a squared minus a plus h squared, okay? Combine two terms in the numerator. Then I can put aside. And the numerator here, this is 1 of h, right? The numerator a squared minus a plus h squared be a squared minus a squared plus 2ah plus h squared. So a squared will be canceled out. You get a negative 2ah plus, no, minus, okay, minus h squared, be careful. And here a plus h squared, a squared h. So you should be able to take one h out of the numerator. Then you cancel it with the h in the denominator, okay? So if you take one h out, it's 2a minus h and a plus h squared and a squared. There's no h in the denominator. There's no factor of h in the denominator. H canceled out. All right, so now you can safely let h go to 0. Okay, so if h go to 0, the numerator is negative 2a, the denominator is a squared times a squared. Right? H is 0. So you, after you simplify, it'll be 2 over a cubed. But you can also express, yeah, let's go back, right? You have to express, yeah, this is yeah, so here, if f of x equals x squared, and f prime a is going to be negative 2 over a cubed. So it's hard to see whether it's, you know, whether this matches the same answer we got before using the formula. So actually, yes, okay? So if we express this form, right, you get negative 2a cubed, right? So that's what we got using the limited definition. Yeah.
So 2 divided a cube, it's not the same as what is 100. How do you make that?
You mean from this to here?
No, no,
Below?
that, no,
Under that.
yes. Minus 2 divided a.
Yeah.
So why, how it's coming back? Minus 2
Times a to the negative 3. Oh. That's
so
the,
is it equal?
yeah, there's the two same. So
So how it's
and that's a definition of the negative power, okay? If you have a to the negative 1n, this is the defined to be 1 over a to it. Yeah, it's the same. Okay. Yeah. Also, we have a x over a to the y is going to be a to the x times a to the negative y. It's a to the x minus y. You can also change it to like that. I hope you can see it. And that's going to be a to the y minus x. Yes. All right, now, if you are if S is a position function of a moving object, okay, that means here's a coordinate line. At here's 0, 1, 2, right? At a given time t, and it is here. Right. At time t, so this is the distance is called displacement. Okay, this tells you the coordinate of the moving object. All right. And the derivative, okay? So you look at f a plus h minus f of a divided by h. Okay, what does that mean? This is actually the average velocity, and when it's point A, right? So when t equals a, and here when t equals a plus h. Okay. So at two different locations. So this is the numerator is the distance it travels. It could be 0. Okay. Then divided by the time, the length of the time, it's h. So this is going to be the average velocity over the time interval from a to a plus h. Okay. So if you imagine if you let h go to 0, that means the time interval is getting smaller and smaller and smaller. So if the limit as h approaches 0, you get f prime a. So f prime a, I have a new notation denoted by v, and that is it's called the velocity. Okay, this is the instantaneous velocity at a, because the time interval shrinks to a point, right? One number a. So the limit, if it exists, that is the instantaneous velocity at that particular point. It's called a velocity, okay? And just realize at the time t, okay? And it's denoted by v. So here's a problem. Let's do it. So given the position function s, which is f of t, that's 10 plus 45 t plus 1. Okay, s is in meter, t is in second. Okay, we want to find out the velocity and the speed at time t equals 4. Maybe we can also find the velocity when it's 0. If we can, you can try this. But anyway, let's find out the velocity and speed. What's the difference between speed and the velocity? Well, velocity, yeah, velocity can be negative. Speed is always a positive number, okay? Yeah, so imagine when you drive on highway, there's a speed limit. Maybe you should put a velocity limit. Cannot drive backward, right? Right, so speed must be between 0 and sometimes there's a lower speed must be between 45 miles per hour and 65 miles per hour. You can drive too slow, they also get ticket. Okay, but most of the time we don't put a lower, because that's really lazy to drive on the side. Okay. But definitely negative speed means, negative velocity means you drive backward, you cannot do that. All right, so given S, so first of all, you write down the expression for the velocity. Velocity should be equal to the derivative of the function, okay? So that's the derivative. Now, at any given time t, so how can I usually use the a here, but let's use t, doesn't matter, okay? So this is going to be the limit as h approaches 0. Here's h, f, t plus h, and ft. Okay? So could be using it, doesn't matter, okay? So now, So you have to simplify the expression and find the limit. So let's yeah, for the simplicity, we don't want to keep writing limit. So I'm going to put, it's 10 plus 45. T should be replaced by T plus H. Wow, that's a very complicated expression. Yeah. I'm tutoring some middle school kids. I keep asking them simplify this expression because I know this comes from calculus. And they're supposed to, yeah, after practice 100 problems that become good. Yeah, have to practice. Okay, so don't make mistakes. All right, so 10 canceled out the sign mistakes, you know, right? Yeah, that was a one student, I remember. Her mom called me and she graduated from Zionsville High School, it's pretty good high school, and she got all A's math. But she went to Bloomington, took calculus one, got a B on the test, okay? And her mom said, well, what's going on? You know, then she complained about the teacher's not good. That's usually do that. Okay, so I said, please send me the scanned copy of the exam. I want to see what kind of mistakes she's making. I found out she learned the concept very well, but just every problem, that was some computation mistakes, tiny bit. Then always like a 10 points, think about, right? Those 2 or 3 points, pretty reasonable. At the end, you only get 75%. It's a B, right? Or B minus. So that's the problem here. Right? I don't know why she always got A's in Zionsville High School. I'm not sure. That's what it says on the transcript. Okay. So we needed to make sure not make mistakes every time. No, occasion is okay, right? All right, so 10 canceled out. Let's say 45 T plus H plus 1. Okay. Then you combine two terms. I can put H on the side, right? And then here's T plus H plus 1 times T plus A plus 1, okay, not H. And here's 45. And even you can put 45 on the side, maybe. T plus 1 minus 45, T plus H plus 1. All right. So that T plus 1 will be canceled out, clearly. So you will get 45, take T plus 1 minus T plus H plus 1. It's only negative H there. All right. So H is canceled out. Now you can save. Okay, you can let H go to 0. Let H go to 0. No, T is fixed. I let H go to 0. So it will be T plus H squared. Okay, so that is a limit, which is the derivative of the function at the T. So velocity, now you have a general formula. Okay, you can do that directly. Just let the T to be 4, right? But you can get a general formula. That's, yeah. Then when T equals 4, you get 45, 4 plus 1 square, which is 25, right? So 5, right? So how do you simplify? It's a 5 square and 45 is 5 times 9, right? So it's going to be 9 over 5. Okay. 9 over 5, this is a meter per second. You find the velocity at a particular point. Okay, so the next problem. find the tangential line at the point 1 and 1, and here's a graph, x equals 2 over 3. Okay, yes, when x equals 1, y equals 1. Now it's harder to draw the graph. Okay, it's harder to draw the graph when x equals 0, y 0. Okay, so the graph probably looks like that. When x equals negative, I think y, this is also defined. Yeah, so this is also defined. So the graph, there's a cusp here. Okay, it's not smooth. It's not parabola. So this, yeah. So but the function is differentiable. Yeah, you can find the derivative for any x, any number which is not equal to 0, but not at the point. Okay, so let's look at this. So you have to say that the slope m should be equal to the derivative of the function at 1. Okay, that's a statement. You clearly know how to do it. So that's the slope of the function. Okay, so the function, of course, the function is going to be x to the 2 over 3. Okay, then I think it's difficult to use a limited definition to find it. We just use a formula. Okay, so f of f prime x is going to be 2 over 3 times 2 over 3 minus 1 using the formula. So it's going to be 2 over 3 x to the negative 1/3. Okay. So using that formula, you get 2 over 3. So that is the slope. So once you find the slope, you can get the equation y minus 1 equals 2 over 3 and x minus 1. So that's the equation for that. Now, are you able to use limit definition to find the limit? This is a pretty challenge. It's not easy. Okay, it is not easy to do that. Yeah, how do you cancel the terms? Okay, so question is, the question is, if you want to use, if you want to use this, how do you simplify it, right? It's not a trivial. Okay. You can do that, but not easy. Okay, I'm not going to give you. Some of you maybe think about figure out how to do it. But you do need the following formula: x to the 1/3 minus a to the 1/3 times x to the 2/3 plus a to the 1/3 is going to be x minus a. Okay. Why? Well, we have another formula, right? We have formula a minus b, a squared plus ab plus b squared is going to be a cubed minus b cubed. Okay. This implies that. Okay. So it will become more and more complicated, a challenge job to find the derivative using the limited definition. Yes, do you have a question?
Yeah, so why did we not go down the route of doing like the x plus 8 minus?
Oh, well, it's the same, but yeah, I just feel like it is much, it is, I cannot explain it anyway, so it is going to be a plus h 2/3 minus 8. Still, you're facing the same problem. If we plug in, No, if you even plug in, if A is 1 does not help, you cannot simplify, you cannot get rid of H easily. Yeah, you cannot get rid of. So I think this is an example tells you, yes, without using the formula we figured out in general, it's harder to find a derivative using the limited definition. Okay, so as this, you can try this. Okay, we can try this. Okay, try this, but does not mean we are able to do that. Not everybody can do that. Okay, so it's so the next section we're going to study is some formulas. We just use formulas to find the limit. Otherwise, it takes too much time and very difficult to find. So first of all, you have a definition of the derivatives, and you find the derivative of some simple functions. Then you try to summarize and trying to figure out formulas so that other people can use it. Don't need to repeat the same job over and over again. Okay, that's the point, right? You don't need it. So we get formulas, then because then you can move on. Other people can just learn how to find the derivative quickly. Yeah, using the formulas. Okay. So that is a development, of mathematics in the history. At the very beginning, like Newton's, like other people figured out the concept of a derivatives, limits. It's not easy, okay? It's really not an easy job. And then we have so many things going on here in the textbook. Some students also ask me, calculus is already very complicated. So beyond the calculus, is there any mathematics there? Beyond the calculus, yes. Mathematics is divided into, advanced mathematics divided into many categories: partial differential equations, abstract algebra, differential geometry, algebraic geometry, blah, 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 You can list like 10 more subjects, okay? And if there's a conference, nationwide conference, and people from different subjects cannot understand each other at all, only the first few sentences at the beginning, okay? So it's quite different from biology, mathematics. Biology, I think even me, I can sit and understand their research, if they explain to me, show me picture, chromosome, right? And all kinds of things, because that's the terminology we already learned in high school biology book. So even this very advanced research, they just tell you that discover something, but the terminologies, the names, so you already learned that. It's different from mathematics, okay? But slowly, there are some genius in the history. That's why they figured out how to, have this whole book, mathematics. That was a couple hundred years ago, okay? They figured out all of them. So that's what I'm learning today. Today we learned how to find the derivatives using definition, okay? And the meaning of the derivative, if it's going to be the slope of the tangent line to the graph of the function. If the function is the position function of some moving object, then the derivative of the position function is just the velocity of the moving object at any given time t. Okay? And we see that we figured out the formula, right, for the derivative of the power function. But more general, it's very difficult, right? And like even like x to the 2 over 3, this power function, if I want to use a limited definition to find it, the limit, it's not easy, okay? Maybe some of you in this class, after I give you this couple formulas, you can figure it out. But so we in the next section, we are going to learn some general rules and also formulas, okay? And so we can combine them and we can find the derivatives of more complicated functions. We're going to learn product rule, quotient rule, blah, blah, blah. and we should able to do all the we should able to find the derivative of the multi-complex function. Now the question is, well, we have to do that. I already have equipment. I can enter, as long as I know how to type the function and click a derivative, I can get the function right away, right? The derivative, yes, like a graphing calculator, I don't know, any a little bit more advanced software you can purchase, you can do that, okay? And why we have to study this? For a couple of purposes. So number one is it's not always you can have this available devices you can use or softwares. Second is we are training ourselves to think problems, improve our correct abstract thinking skill. Okay, so that is what we need actually. We should learn from colleges. Okay, it's not. We not needed to learn some basic, things how to solve this problem, that problem. I remember that some companies that when they recruit people, and their only requirement is, hey, do you have a master's degree in mathematics? I don't care whether you. And it's financial institute. It's nothing to do with calculus. Yeah, but they want to hire you just because they believe you have this skills, so that can help them to how to solve some financial problems, and do some prediction, or you like statistics. We get huge data, some company like Facebook, right? And the question is, how can you use this data you collect to do some analysis and then predict something, give advice to some companies for investment. And the more that, if you can do the data analysis, then you make the company more profitable, but that you do need this is a place where you need a mathematics, especially statistics. Okay, so very few students still choose statistics as your major, even you're good in math, but I really encourage you to do that. Okay, I find out the bigger data, the demand is getting high and high in the future. Okay, so you should think about this option too. Let's take a quiz today.